Hello and welcome back. Today we're going to go through 7.1 on the inverse of sines, cosines, and tangents. Now, something that you hopefully remember from your college algebra days, for a function to have an inverse, it has to be a one-to-one function. So sine, we'll start with sine. The sine graph, if we have unlimited domain, clearly is not a one-to-one. Remember, one-to-one, it would have to pass not only the vertical line test to make sure it's a function, but also the horizontal line test. And here, we'll do a quick rough sketch in here. So sine of 0 is 0. Sine of pi over 2 is 1. But then after that, once we get past pi over 2, it starts dipping back down. Well, the problem with that is if we allow it to dip back down, it will no longer pass that horizontal line test and it will not be a one-to-one function. So what we're going to do is restrict the domain. We're going to stop on the right side at pi over 2, and we're going to go backwards into negative territory. So sine of negative pi over 2, remember your unit circle, negative pi over 2 is the same as the 270 degrees, the 3 pi over 2, and the output is negative 1. And after that, again, it would turn back around if we kept going and fail the horizontal line test. So we work with this when we have these y equals sine x, and we're looking to do inverses. We're going to restrict the domain. We'll go from negative pi over 2 to pi over 2 only. And we are allowed to use those endpoints. As far as the range of values, we have them all negative 1 to 1 there. Same values we would have if we let it keep going with an unrestricted domain. So there's two common notations for the inverse. So this is saying the inverse of function, the sine function. It's also referred to as the arcsine. These both mean the same thing. It's asking you to figure out what angle gave you a sine value of x. And just like in your college algebra days, as far as inverse functions, domain and range switch roles. So then for the inverse, the domain is now negative 1 to 1, and the range is negative pi over 2 to pi over 2. So a couple quick examples. Find theta such that theta is the arcsine of negative root 3 over 2. So one thing we can do is take the sine of both sides. So sine theta is sine of the arcsine of negative root 3 over 2. So sine theta is negative root 3 over 2. So we want to figure out what angle on the negative pi over 2 to pi over 2 range of values gives us a negative root 3 over 2. So I'm just going to draw half of our unit circle since we're sticking from negative pi over 2 to positive pi over 2. And we want the sine to be negative root 3 over 2, so that's down here. And if our sine is a root 3 over 2 up here, it would be 60 degrees pi over 3, so down here it would be negative 60 degrees. So theta is negative pi over 3. So this one, recall, is at 1/2 negative root 3 over 2. All right. Next one that we get to play with. Do the arcsine of the sine of negative pi over 4. So this one, as expected, is the negative pi over 4, the arcsine undoing what the sine did. That won't always happen. Negative pi over 4 is on our required interval of negative pi over 2 to pi over 2. So we get to keep it that way. But if they ask me for the arcsine of the sine of, say, 2 pi over 3, that won't give me a 2 pi over 3. Reason being, 2 pi over 3 is not on our required negative pi over 2 to pi over 2 interval. So what we do is we go to the unit circle and find a value that matches that is within our domain for this problem. So we would have a 2 pi over 3. So here is 1 pi over 3, 2 pi over 3. We're talking about sines, so we want the same sine value, in other words, the same y value. So our partner within the required restricted domain here is at pi over 3, 60 degrees. So the arcsine of the sine of 2 pi over 3 is actually pi over 3, since that is on our required domain of negative pi over 2 to pi over 2. Let me show us something like the arcsine of 2. We'll use a let line there. Let theta equal arcsine of 2. So then sine theta is sine of the arcsine of 2. But here's the problem. Then we're claiming that the sine of theta is equal to 2. Sine theta is between negative 1 and 1. So this is undefined. That one is not possible. This is not in our domain. Our domain, remember, was negative 1 to positive 1, which, remember, is the range of the original sine function. Domain and range traded when you're working with inverses. All right, so next up, we get to play with our friend, the cosine. And again, I'll start with one of my world-famous beautiful sketches. So the cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi, we are at negative 1. And once we get beyond pi in our unit circle, then our cosine values start rocking back around. Picture the circle in the unit circle. So 0, here's our 1, here's our negative 1. After that, cosine values start repeating. The Q3 ones and the Q2 ones are the same. So I'd have to stop there and that gives us the full range. It would start picking back up. Same thing back here. If I wanted to try going in a negative direction, well, the Q4 cosine values are the same as the Q1 cosine values. So here we're only keeping from 0 to pi for our restricted domain. Our range, as you can see, -1 to 1 still. Which means that for our inverse function, y equals arc cosine of x, and you'll see it written either of the two ways. Those two are equivalent. Domain and range switch from the original. So our domain was 0 to pi, so now our range is from 0 to pi. Our range was -1 to 1, so now our domain on the inverse, -1 to 1 again. Alright, so we'll play with them. Same ideas. We're basically given an output and asked for the input. What angle gave us this as a result? So for example, they might ask us for the arc cosine of -1/2. We can use a let line. Let theta equal arc cosine of -1/2. Take the cosine of both sides. So cosine of theta is cosine of the arc cosine of -1/2. So basically what we're saying here is cosine theta is -1/2. Which angle has an output of -1/2 on that interval of 0 to pi? So if you think back to our unit circle, and this time we're interested in 0 to pi as opposed to sine when we're interested in -pi/2 to pi/2. So our cosine is -1/2. Well, here at pi we're at -1, 0. And then just kind of counting backwards, we have -√3/2 +1/2. At the 45 we have -√2/2 +√2/2, and then at the equivalent of the 60 we have the -1/2 +√3/2, and then finally at the top we have the 0, 1. So our cosine is the -1/2, so that's this guy up here, the equivalent of the 60 degrees, but on this side of it. So I want pi minus 60 degrees. So that's 3 pi over 3 minus 1 pi over 3, so that is 2 pi over 3. So that is our angle. Theta is 2 pi over 3. So that's the arc cosine of -1/2. So remember, when we had a sine that gave us a 2 pi over 3, that was not in our domain. Cosine, however, it is in our domain. And the reason for that is just trying to avoid failing the horizontal line test. All right, let's try another one. So do the arc cosine of the cosine of, let's say, pi over 11. Well, pi over 11 is on our closed interval of 0 to pi, so we get to just use the pi over 11 That is our angle. But if they asked us for the arc cosine of the cosine of 11 pi over 6, I can't just say that's 11 pi over 6. 11 pi over 6 is definitely not on our list of 0 to pi. It's not on our required interval. So we'll have to sketch it. As you've seen from my sketches, doesn't have to be a beautiful work of art there. So let's see, so pi over 6, well, here is pi, so that is at 6 pi over 6. So this guy was at 3 pi over 6. So here is 9 pi over 6. So 10 pi over 6, 11 pi over 6. So we're 30 degrees short of making 2 full laps around the unit circle. So we want an equivalent cosine, but we want it to be on the required 0 to pi interval that we need for the cosine. So the equivalent would be up here, instead of 30 degrees below, 30 degrees above the axis. So on this one, this would be worth pi over 6. Pi over 6 does have the required feature that it has the same cosine value, but it is on our interval from 0 to pi. Alright, so then we look at the tangent, specifically the inverse tangent is where we're going with this. So recall for the tangent, y equals sine x over cosine x. So this is undefined where cosine x is 0. So in other words, undefined at plus or minus pi over 2, plus or minus 3 pi over 2, plus or minus 5 pi over 2, any odd, plus or minus 2n minus 1 pi over 2. Now, since we also want to pass the horizontal line test, we don't want to draw all of the repeating tangent function, so we just want sort of one group of it. So in this case, we'll just use that first one, and we'll go from negative pi over 2 to pi over 2. So remember, sine of 0 is 0. We're undefined here and here at pi over 2 and negative pi over 2. At pi over 4, sine and cosine have the same output, so we have a 1 there. At negative pi over 4, they have opposite signs, so their output is a negative 1. So that's our general shape. So for the original tangent, our domain with our new restricted, the new restricted domain, just like the sine, we're looking negative pi over 2 to pi over 2. Range, as you can see, infinite number of values, negative infinity to infinity. We can go as low or as high as you want. So that means for the inverse, y equals arctangent of x, either written this way or written out arctangent of x. They switch, so now our domain is unrestricted when we're working arctangent problems. Any real number, we can find the arctangent. Our range, though, is going to land us on pi over 2. My apologies. Open. Since we're undefined at pi over 2, open paren on pi over 2, negative pi over 2, pi over 2. That should be open. My apologies for the error there. We're undefined at pi over 2. We're undefined at negative pi over 2. So we would have to exclude those values. So this would be open. All right. So then we'll be asked to do things like find the exact value of the arctangent of, I'll write that so you can read it, arctangent of negative 1. Again, we'll use a let line, let theta equal arctangent negative 1. So tangent of theta is negative 1. So we're basically asking on our negative pi over 2 to pi over 2 interval what angle has negative 1 as the end result. Well, that, looking at our restricted unit circle, sine and cosine have the same absolute value. Well, that puts us either up here or down here. Excuse me, the fact that they have opposite signs puts us down here in Q4. So that's 45 below the axis. So theta here is negative pi over 4. So then the last thing they have us doing is basically just finding the inverse of a trig function. The process is the same as your college algebra days. The only new thing is now we have these trig functions, sines and cosines and tangents to play with. So let's start with f of x is 5 sine x plus 4. Plus 4 is not in parentheses there. Typically what I would do with my college algebra classes is first get rid of the function notation and we'll get it back later. So 5 sine of x plus 4 is our new y value. Then for the inverse, remember on an inverse function, x and y trade roles. So now x is equal to 5 sine of y plus 4, and then we're solving for y. So we'll subtract 4 on both sides. X minus 4 is 5 sine of y. Divide both sides by 5, so sine of y is x minus 4 all over 5. So then y is the arcsine of x minus 4 over 5. So that is our inverse function of function f. So f inverse of x is the arcsine of x minus 4 all over 5. And again, remember these two mean the same thing. Either arcsine written out or sine with the negative 1 superscripted. Notice this is not the same as the reciprocal of the sine function. Cosecant is the reciprocal of the sine function. So this is asking for something else. This is just the decided upon notation, just like this was the decided upon notation for inverse. Now, as far as the domain and range of our new one, the domain of f, we can plug in anything we want to a sine function. A sine function by itself will spit out anything between negative 1 and 1. And then we did a couple things to that. our amplitude was 5, so now we're bouncing between -5 and +5. And then this +4 outside, remember that moves everybody up 4. So our range value, it would go down to -1. This says it would go down to -5. Then we move that up 4 units. -1 is where we'll bottom out. And we can't actually reach that. We would top out at 5. We moved it up 4. So now we're topping out at 9. So for F inverse, our domain is now -1 to 9. And our range, though, is -infinity, infinity. Now there is one other option as far as figuring out this range, rather than reasoning it out with what would happen with the original function, the amplitude, and moving it up and down. One other option to get to the range, and I'll just show you the setup. Before we get to the inverse or any of that, is to just get the sine by itself, or the cosine, whatever the trig function is by itself. So y minus 4 all over 5 is sine x. And since sine x is between -1 and +1, y minus 4 all over 5 is between -1 and 1, and solve that thing for y. Either way will get you to the same answer, either reasoning it out just by what's happening with the outputs, the stretching and the shifting, or you can do a little algebraic manipulation. They'll both get you there. Alright, so then they have us doing a little bit of work with some equation solving. So this one will solve 6 arcsine of x is worth opposite of pi. Well, I want to eventually get that x by itself, so let's move the 6. So now we're saying the arcsine of x is -pi over 6. We know that when we're talking sines and arcsines, we're restricting this to -pi over 2 to pi over 2, as opposed to cosines, which would go from 0 to pi. So we want our y value to be negative pi, let's see, our sine, we'll just take the sine of both sides before we finish that. So sine of the arcsine of x is equal to the sine of -pi over 6. So x is the sine of -pi over 6. As I started to mention, that's down here. -pi over 6, pi over 6, 180 over 6 is 30 degrees. So we're 30 degrees down. So that would put us at √3 over 2 for the x, -1/2 for the y. So our sine then is -1/2. All right, so for those of you doing the problems out of the textbook, I would try 7-1, 15 to 25 odd, 39 to 77 odd, or those of you that are looking to do it on my Math Lab, I'll upload it on the My Math Lab website. If you have any questions, please get in touch. Otherwise, stay safe out there, and I'll see you next time.